Hello, my name is Nagasaigovich and today I am going to talk about advantages of circular waveguides. The waveguides. You have to know what is a waveguide. A waveguide is an electromagnetic device which are occurred which is used for more than 3 GHz frequency. They have very less losses due to the solid dielectric needed to support the conductor, and the metallic tube can be used to transmit electromagnetic wave at above frequencies. And we have to know what is a waveguide. The hollow metallical tube of uniform cross section for the transmitting electromagnetic waves by successive reflections from inner walls of tubes is called waveguides. The basic features of waveguides may be used to carry energy between pieces of equipment or over longer distance to transmit power to an antenna or microwave signals from antenna to receiver. Waveguides are made from copper, aluminum, and these metals are extruded into long rectangular and circular pipes. And the electromagnetic energy to be carried by a waveguide is injected into one end of the waveguide, and the electric and magnetic field associated with the signal bounce off the inside the walls, and forth it progresses down the waveguide. The EM field configuration within the waveguide. In order to determine the EM configuration within the waveguide, the Maxwell equations are used, and such solutions rise to be solved. The Maxwell equations can be used to solve the subject of appropriate border conditions. Such solutions can be raise the number of the field configurations, and thus can be used and can be known as the mode. This is how the electric and magnetic field looks like. And to traverse, there are different types of modes, which is TEM mode, TE mode, which what is TEM mode? Traverse electromagnetic wave mode, in which the electromagnetic wave and magnetic wave, electromagnetic component and magnetic component, both are kept zero, which is traverse electromagnetic wave. Next is the traverse electrical wave, where the electrical wave is kept zero and magnetic wave is traversed. Then is TM mode, in which the magnetic wave not kept zero and electrical wave is not equal to zero. The hybrid HE, where we will send both of them all at once. This is how TE and TEM mode work. And this is the rectangular waveguide. This is an example of rectangular waveguide. And circular waveguide, a hollow metallical tube of uniform circular cross section for transmitting electromagnetic waves by successive reflection from the inner walls is called circular waveguide. The circular waveguide is used for special applications like microwave techniques. It has the advantage of greater power handling capacity and low attenuation for a given cutoff wavelength. However, the disadvantage of somewhat greater size and weight. The polarization of the transmitted wave can be altered due to the minor irregularities of the wall surface of the circular waveguide, whereas the rectangular waveguide has the polarized fixed frequency. And this is the different types of waveguides. And the description is the main dominant mode of the circular waveguide is TE11, where M and N is the first subscript is used for the electric field around the circumference of the waveguide, and the second subscript N indicates the half wavelength used for circumference, or subscript used for the half wave variation across the diameter. Advantages are the waveguide can be several advantages over two-wire and coaxial cable. The skin effect tends to increase the resistive capacitance of the conductor, although energy transferred in coaxial cable is caused by electromagnetic motion. The magnitude of the field is limited by size of the current carrying area of the inner conductor. The small size of the center conductor is even further reduced by skin effect, and energy transmission by coaxial cable becomes less efficient than waveguides. The dielectric losses are also low in waveguides than the two-wire and coaxial transmission waveguides, and the dielectric in waveguides in air, which has much lower dielectric loss than convention insulating materials. However, the waveguides are also used to subject the dielectric breakdown caused by standing waves. The power handling capability is another advantage of waveguides. The waveguides can handle up to more than coaxial cables and can be used for the capability of directly related to the distance between the conductor. The disadvantages is that it is primarily for the low frequency. Limitations of the waveguides is that it is bulky and it is hard to install and has hollow shaped pipe. Thus these joints are required, and so then special joints are required. The cost is more and decreases the practicality of the waveguides. The applications of the circular waveguides are as the main applications are rotating joints in a radar is connecting the horn antenna feeding a parabolic reflector. The T01 mode suitable for long distance waveguide transmission above 10 GHz. Short and medium distance broadband communication could replace or share coaxial and microwave links to reduce attenuation loss, and it can reduce attenuation loss. It can also be used to operate above certain frequencies. And conclusion is that the waveguides can be used to guided pipes and hollow pipes and dielectric coated surfaces, and they have TE mode and TM mode, and it has propagated cutoff frequencies. And waveguides have lower frequencies than other thing and has a metallic waveguides.